Calculation on vibration of string. Let's solve this question on vibration of string. If tension is maintained on a stretched string of length 0.6 meter such that its fundamental frequency of 220 Hz is excited, determine the velocity of the transverse wave in the string. Now, the first thing is that please bring out your parameters from the question. It's very important. Now, we can see that the length of the string was given to us to be 0.6 meters. So I'm going to say L is equals to 0.6 meters. Now, such that its fundamental frequency was also given to us. So I'm going to say the frequency is equals to 220 Hz. Now, determine the velocity of the transverse wave in the string. We are asked to find the velocity like that. So I'm going to say V is equals to unknown because we are looking for the velocity. Now, from the question has given us a clue. Now, and what is the clue? This is the clue here. You can see fundamental frequency. Now, the smallest possible vibration that you can have in a string is when it vibrates in its fundamental mode. And when it's vibrating in its fundamental mode, then the frequency you are going to obtain is fundamental frequency. Now, how do you draw the fundamental mode of vibration of a string? Now, this is it. Now, this is how to draw the fundamental mode of vibration of the string. So, here like this, you have something like this. Now, this is how to draw the fundamental mode of vibration of a string. So once you are able to draw this, then you know that the distance from ear to ear is the length of the string. So this is the length of the string. But now, if you look at the wave that is being formed, the standing wave that is being formed, you will discover that this standing wave is lambda over 2, which means half a wavelength, right? Because you know that when you have a wave like this, this is lambda because this is a complete cycle. But when you have something like this from ear to ear, that is half a wavelength. So from ear to ear like this to ear like this is what? Lambda. But from ear to ear is lambda over 2. That is half a wavelength. You understand? It's lambda over 2. So we have something like this. So this is going to give us lambda over 2. So you don't really need to cram anything. You don't need to cram anything. So what you're going to do here now is that you're going to make the lambda the subject of the formula. Now, if you're going to make the lambda the subject of the formula, then you're going to have lambda equals to 2L, right? Because you're going to cross multiply here, lambda equals to 2L. So once you do that, then the next thing is that you remember the equation of wave. The equation of wave, which is velocity is equals to frequency times what? Lambda. But don't forget that your lambda is actually 2L from here. Let me write the L very well. So it's actually 2L from here, right? So meaning that your velocity is going to be frequency times, instead of lambda, you can put 2L, right? So you can put 2L. Now, from there, you can actually substitute your values here right now. So which is going to be V, because they're asking us to find the velocity. So V is equals to frequency, which is 220, then times, what is this? 2 times, what is this? The length. And what is the length? Is 0.6. Then I can say this 220 times 2 times what? 6 over 10. And this is going to cancel this, right? So I'm going to have 22 times 2, that's 44 times 6. And 44 times 6 to give us, that's 264. And what is the unit of velocity? That is meter per second. So that is our answer.